Hello everyone, welcome to the online learning series. We are dealing with the chapter motion in a plane. So in the previous session we had discussed about the basics of vectors. Today we are going to continue to learn about vectors. Today in this session I am going to teach you about a type of vector called unit vector. So what are unit vectors? Now, if a vector has magnitude equal to 1 and direction is pointed in a particular direction, then we are going to call such vector as unit vector. So, unit vectors will have magnitude equal to 1. So, vectors should have magnitude as well as direction. Unit vectors will have magnitude which is equal to 1, that is 1 centimeter, 1 unit. It could be 1 centimeter, 1 meter, anything. So, it is unit magnitude and its direction is pointed in the direction of the given vector. Say I have a vector A. As told earlier, vectors are denoted by this symbol. Now, this is a vector. This vector A will have magnitude and direction. How do I represent the magnitude of this vector? By writing this modulus vector A. So, modulus of vector A or just simply A can be called as the magnitude of this vector. So, modulus of A gives me the magnitude of the vector. And how do I denote its direction? Using A cap. And this A cap is nothing but the unit vector. From this you can say that the unit vector specifies the direction of the given vector. Now this unit vector is representing the direction of this vector, given vector. So this is the magnitude and this will be the direction. Since its magnitude is equal to 1, if I multiply that magnitude to this magnitude of vector A, it doesn't change anything. So if I say the magnitude of this vector is 5, then 5 into the magnitude of this vector is 1, which is nothing but 5. That doesn't change anything. Therefore, unit vectors are always used, or it always represents the direction of the given vector. Now let us define the unit vector. So unit vector is a vector. Unit vector is a vector with magnitude equal to 1 and its direction is in the direction of the given vector. So if A is the given vector, then A, just if I write A or modulus of A, that gives me the magnitude, and A cap is the unit vector. Always we are going to denote a unit vector using a cap. So if I anywhere if I use this cap, that just means it's a unit vector. And I can also write the unit vector is equal to vector by its magnitude. So unit vector is vector by its magnitude of vector. The given vector by the magnitude of that vector gives me the unit vector. Next, let us discuss the orthogonal unit vectors. Now if I consider a three-dimensional coordinate system, so this is x-axis, y-axis, z-axis, then the unit vectors in case of this are represented by I cap, j cap and k cap. So what are unit vectors here? Now if I say this is 1 unit, then this will be I cap. That is, I cap is the unit vector along x-axis and j cap is the unit vector along y-axis and k cap is the unit vector along z-axis. If I want to represent a vector which is acting along the x-axis, then I am going to use the unit vector I cap. Say the force is acting along x-axis and the magnitude of force is 5 Newton. 5 Newton of force is acting along x-axis. Then I am going to write this as 5 I cap. So 5 is the magnitude of this force and I cap is the direction in which it is acting. Then if the force is acting along y-axis, then I am going to write it as 5 j cap. And if it is along z-axis, then we are going to write as 5 k cap. So unit vectors just represent the direction of the vector. Now if I say I have a vector somewhere here in the plane yz, it is in the plane yz and its magnitude is 2 here, like 1.5, and here it is 1.3, something like this. Then how do I represent this point in vector notation? Then I am going to write this as 1.5 j cap plus 1.3 k cap. That is the magnitude of this vector which I am going to represent here is 1.5 in the direction of y-axis. Since I have written j cap, it is in the direction of y-axis, and it is 1.3 in the direction of z-axis. Therefore, this is how I am going to represent a vector using unit vectors. And these vectors I cap, j cap, k cap are called as orthogonal unit vectors, since they are all perpendicular to each other. All the three I cap, j cap and k cap are mutually perpendicular to each other. Therefore, we call them as orthogonal unit vectors. And the magnitude of I cap is equal to the magnitude of j cap is equal to the magnitude of the k cap, which is equal to 1. Its magnitude is always equal to 1, and I cap directs in the direction of x-axis, j cap directs in the direction of y-axis, k cap directs in the direction of z-axis. And today we are going to discuss about the resolution of vectors. It's a very important topic. Now let us see what is resolution of vector. Now I want to represent this vector A using these two vectors A and B. For that, since the magnitudes of A and B are very different from the magnitude of A, to match them, what I am going to do is I will multiply this A, vector A, with a real number n. So let me say this is what the new vector I am going to get when I multiply a real number n to this, and a new vector b when I multiply a real number m to this vector b. Now let me just draw a parallel vector here, somewhere here. So I'll get this n a vector and vector mb. That is, what we have done here is, by multiplying real numbers n and m to these vectors a and b, I have expressed this a, vector a, in terms of a and b. So I can now write this vector a as equal to na plus mb. This vector a is expressed in terms of this vector a and b here. So this way of expressing a single vector into two or more component vectors is called as resolution of vectors. So here we have broken a single vector into two different vectors of different magnitude and different directions. So these vectors a and b, they don't have same magnitude as this vector a, and they do not have same direction as this vector a. Their magnitudes and directions are all completely different, and we are expressing this vector a in terms of a and b. So expressing a single vector by using two or more component vectors which are having different magnitudes and different directions is called as resolution of vector. Now let us write the definition for resolution of vectors. The process of splitting of a single vector into two or more components is called resolution of vector. So resolution of vector is the process of splitting of a single vector into two or more component vectors, and this process is called as resolution of vectors. Now if I say I have a vector A, then this vector can be split into two components, one along the x-axis, another along the y-axis. And the component which is along the x-axis will be named as Ax, and the component which is along the y-axis is named as Ay. So I have two components of this vector A, one along this x-axis which is called as the horizontal component, and which is the one along the y-axis is called as the vertical component. Therefore, I am splitting the single vector into two component vectors. That is, I have resolved this vector A into two component vectors. We are going to always resolve these vectors into rectangular components. So you know rectangular components are nothing but the components which are making 90 degree or which are perpendicular to each other. So you can see here the component Ax and Ay are perpendicular to each other. Therefore, we are going to resolve a vector into our rectangular components. Now let us find out what is this component Ax, the value of component Ax in terms of this A, and the value of component Ay in terms of the vector A. Next, let us find out what are the values of Ax and Ay. Now this is the vector A. I am going to resolve this vector A into two rectangular components. One is Ax, which is this, and another one is Ay. And this angle is theta. So what is theta here? Theta is the angle between the horizontal component Ax and the vector A. So theta is the angle made by this vector A with the horizontal component. Next, I'll make some construction here where I'm going to draw a perpendicular from this A to this horizontal component and also to the vertical component. Next, if this is Ax, so here there is a formation of a rectangle, then if this is Ax, then the value of this also will be Ax, and if this is Ay, this side also becomes equal to Ay. Now let us name this rectangle. I'll name this as O, P, Q and R. So this whole thing will be Ax and this will be Ay. Now let us find out what is Ax and Ay. First of all, I am going to write down this as, I'll mark an arrow mark here. So you'll get to know that OR plus RQ gives me this vector OQ. Therefore, we can write this as OQ. So from the triangle, we'll mention the triangle here. Which triangle I have taken? ORQ. From this triangle ORQ, I can write vector OQ is nothing but equal to vector OR plus RQ, right? And what is OQ? It is nothing but vector A, and that is equal to AX plus AY. So OR is nothing but AX and this is AY. And we know AX will be equal to Ax I cap. Can I write this in this form? Because vector Ax is having magnitude Ax and it is in the direction of x-axis. Therefore, I can write the unit vector I cap. And similarly, we know Ay is magnitude is equal to Ay and it is in the direction of y-axis. Therefore, I am going to write it using j cap. Next, the vector A can be written as Ax I cap plus Ay j cap. So this vector A is equal to Ax I cap plus Ay j cap. In the next step, I am going to consider the trigonometric functions. First, let me see what is cos theta. Now in this triangle, in this right angle triangle, if this is theta, then what will be cos theta? As you all know, cos theta is adjacent by hypotenuse. The formula for cos theta is adjacent by hypotenuse. So this cos theta will be equal to, if this is theta, this side is the opposite, this becomes the adjacent. Since this forms a 90 degree, therefore this will be the hypotenuse. Therefore I can write adjacent as equal to OR by and hypotenuse equal to OQ, or this can be written as OR is nothing but AX by OQ is A. Therefore, if cos theta is AX by A, then the value of AX will be equal to A cos theta. This value of AX is A cos theta. Next, let me write AY in terms of the vector A. Similarly, here I am going to consider another trigonometric function, sin theta. What is sin theta? Sin theta is equal to opposite by hypotenuse. Now, which is the opposite side here? It is AY by hypotenuse is A. It is nothing but OQ. Therefore, AY can be written as A sin theta. So, the components AX will be equal to A cos theta and AY is equal to A sin theta. Now, let me write down AX is nothing but A cos theta and AY is nothing but A sin theta. Whenever you resolve a vector into two components, you are going to take one component as A cos theta and the other component as A sin theta. So, let me consider another case. I have this vector A, these are the components, and I will mention the angle theta here, this side. Then this side becomes A cos theta. This component is A cos theta and this component becomes A sin theta. Where I am mentioning this angle theta is very important here. So, if theta is the angle made by the vertical and the vector, then this component, vertical component becomes A cos theta. Or if this theta is the angle made by the vector with the horizontal, then the horizontal component becomes A cos theta. Remember this. I am going to consider this as equation 1 and equation 2. Now let me squaring and adding equations 1 and 2. What do I get if I square and add them? So, squaring the first equation, I am going to get A square cos square theta plus the second equation RHS A square sin square theta is equal to AX square plus AY square. So, this is what I am going to get here. If I take common A square as common, then this will be A cos square theta plus sin square theta. This is equal to AX square plus AY square. You know the formula cos square theta plus sin square theta is equal to 1. Therefore, A square is equal to AX square plus AY square, or A is equal to under root AX square plus AY square. This is how you are going to find the magnitude of the vector A. So, whenever you want to find the magnitude of vector A, you have to use this formula. This is how we are going to find the magnitude of vector A. Next, let me divide the equation 2 by 1. What do I get? Equation 2 is A sin theta by equation 1 is A cos theta, which is equal to AY by AX. A and A gets cancelled. Sin theta by cos theta is tan theta, and this is equal to AY by AX, or theta is equal to tan inverse of AY by AX. So, if I want to know the direction of vector A, I can use this formula theta is equal to tan inverse of AY by AX. From this, I can know the direction of the vector A from the horizontal. If I get to know this angle, then I can say in what direction the vector A is being aligned from the horizontal. So if I consider this as vector A, then the rectangular components of vectors will be Ax and Ay. So this is vector A. These are the two rectangular components of this vector A. This is Ax, this is Ay. Now if I consider this angle as theta, then Ax will be equal to A cos theta and Ay will be equal to A sin theta. Therefore, I can write vector A as equal to Ax I cap plus Ay j cap. And to find the magnitude of this vector A, I am going to write under root Ax square plus Ay square. Whenever this case is only when you have rectangular components. So if you want to find the direction in which the vector A is aligned from the horizontal, you are going to write theta as equal to tan inverse of Ay by Ax. Remember these things. Now we are going to resolve the vector into three rectangular components. If I have a vector in 3 dimensions, that is in space, then let me consider this is a vector A. How do I resolve it? I need to resolve it into 3 rectangular components because I do have 3 coordinates. Therefore, this will be one component Ax and this is the second component Ay and this will be the third component Az. Therefore, this vector A is written as Ax plus Ay plus Az, or I can write it as Ax I cap because Ax is the component along x-axis. Therefore, I am multiplying the unit vector I cap. Similarly, for Ay, it is Ay j cap plus this is Az k cap. So, this is how I am going to represent the vector A. If I want to find out the magnitude of this vector A, then I am going to write it as under root Ax square plus Ay square plus Az square. This gives me the magnitude of this vector A. So, if you want to represent the position vector R in space, then that R will be equal to x I cap plus y j cap plus z k cap. And if I say that this R, somewhere the position vector R is having coordinates 2, 5, 6. So, then how do I write this position vector? R will be equal to 2 magnitude 2 along x-axis plus 5 along y-axis plus 6 along z-axis. So, this is how you are going to represent the position vector in space. Now, when I have a vector in space, then I am going to resolve it into 3 rectangular components. Let us see how we are going to resolve it. So, first what I am going to do is, I will draw a perpendicular from this vector A to this plane xy. So, if I say this is x, this is y and this is z. This is the xz plane where I am going to drop a perpendicular from this A. And let me join a line here. That is, I will draw a perpendicular from this point to the z axis. Okay. Similarly, I am going to draw a perpendicular from this vector A to the yz plane. Now, let me draw this. And let us join these 2 points here. And let me construct a cube here. I will name this as O, N, M, and let me name this as L. Let me mark the angles. So, if this is vector A, then the angle made by the vector A with this x-axis, I am going to name this as alpha. And the angle from the vector A to the y-axis as beta, and the angle from vector A to the z-axis as gamma. I can write Ax, that is the x component of the vector A, as equal to A cos alpha. Similarly, the y component of vector A, Ay, can be written as A cos beta, and the z component of vector A, it can be written as A cos gamma. Now, let us take up the triangle OPA. So, first let me draw this diagonal here from O to P. I have drawn a diagonal from O to P. Next, this is the direction. This is how I am going to mark the direction. So, from O to P, then P to A gives me OA. Therefore, I am going to write this up. Triangle OPA, I can write OA is equal to OP plus PA. Or I can also replace this PA by ON. So they both are opposite and therefore they will be equal. The sides will be equal. PA can be written as ON. Let me write OA is equal to OP plus ON, because I have just replaced PA by ON. So if I consider the triangle OMP, then OM plus MP gives me this OP. Therefore, I can write in the triangle OMP, OP is equal to OM plus MP. And can I substitute this OP to this equation? So, let me write this equation as 1, substituting to 1. Equation 1 becomes OA is equal to, in place of OP I am going to write this as OM plus MP plus ON. OA is what? OA is nothing but vector A. This is the vector A. What is OM? OM is the component along x-axis. Therefore, this is AX. Or I can write this as AX I cap because it is along the x-axis. Plus, what is MP? MP can also be written as AZ. It is parallel to this side. Therefore, this is AZ, which is along K cap. Plus, what is ON? ON is nothing but AY, and it is multiplied with j cap. Therefore, vector A is AX I cap plus AY j cap plus AZ k cap is what we are going to get using this rectangle components. In today's session, we have studied about unit vectors and resolution of vectors. We have learned that we can resolve a single vector into 2 or more components. In the next session, we are going to study about the addition of vectors. Thank you.